Hello, and welcome back to our video series about three-dimensional vectors. Today we're going to be discussing the angle between three-dimensional vectors. If you recall, when we discussed two-dimensional vectors, you had a formula for the angle between two vectors, but you didn't actually need it, because in 2 dimensions, you could have a vector here and perhaps a vector that goes this way. And you could always do some creative math. You could figure out what this angle is, you could figure out what that angle is, and you could subtract the two. Or you, depending on where you were, you could add them. So the angle between two-dimensional vectors, you didn't actually really need a formula. But when you get into 3-dimensional space, you have that third dimension that makes life just a little bit more complicated whenever you're trying to find the angle between two vectors. So I always advise people to use the formula for the angle between two vectors. This formula is exactly the same as it is for 2D. You're just working in 3 dimensions. So in the top of the formula, you calculate the dot product of your two vectors. And in the denominator of your fraction, it's the product of the magnitude. And remember, your magnitude is just like the Pythagorean theorem. You square all of the components. I guess we should put x and y here instead of a, b, and c. X squared plus y squared. And you do the square root. Again, be aware that this is the cosine of the angle is equal to the dot product over the product of the magnitudes, meaning that you're going to have to probably use an inverse cosine at some point. So let's apply the formula. Find the angle between the two vectors. So first, calculate your dot product of u and v. U dot v. So the dot product of u and v, we have negative 28, 7 times negative 4, plus negative 3, and then plus negative 3 times positive 4, which is negative 12. So u dot v, negative 28 plus negative 3 plus negative 12. Gives us negative 43 for the numerator of our fraction. Now let's calculate the denominator. To do that, we need to find our magnitudes. Again, to keep your answer exact, you want to wait till the last possible moment to put any decimal approximations into your calculator. So the magnitude of u is, the negatives don't really mean anything when you're calculating magnitude because you're squaring them. So just do 4 squared plus 1 squared plus 3 squared. I find that I make less errors that way. So 4 squared is 16, 1 squared is 1, and 3 squared is 9. So 16 plus 1 plus 9 is 26. So it's the square root of 26. I know all of you good math students out there will want to reduce your radical, but honestly, I wouldn't mess around with it at this point because you're just going to end up taking the inverse cosine. So there really is no point. Now to find the magnitude of v, you just do 7 squared, which is 49, plus 3 squared, which is 9, plus 4 squared, which is 16, and it's the square root of 74. So now, once you find all your individual parts, go ahead and plug it into your formula. So you have negative 43 over the square root of 26 times the square root of 74. And just to make life simpler on myself, I'm going to go ahead and multiply 26 and 74. And my sole purpose for doing that is when I punch it into my calculator, I'm not having to worry about parentheses. So when I go to my calculator, I'm going to type in the inverse cosine of negative 43 over the square root of 1,924. Make sure your calculator's in degree mode before you start. Most of the time when we deal with vectors, we want them to be in degree. If we ever want them to be in radians, your directions will tell you so. And you're going to get a decimal. It's okay. The angle between these two vectors is 168.61. The only other thing we need to discuss is parallel vectors. And to calculate parallel vectors, there's a couple different ways to do it. One way is to think about the fact that if two vectors are parallel, that means that they don't touch each other. Now, they can be going opposite directions and they can have different lengths. So these two vectors here would be parallel. But the key thing is that they're kind of going in the same direction. They have the same slope. So if you have two vectors that are parallel, then the angle between them will either be 0 or 180. So when you're doing this calculation, if you pop up with a 0 or a 180 when you do your inverse cosine, that tells you that your vectors are parallel. They will also be scalar multiples of each other. So if you look at this vector 3, 4, 5, and 30, 40, 50, this vector, the second vector here, is just 10 times 3, 4, 5. So since this vector is going to be moving in the same direction, x, y, and z, that the original vector is, it's just going to be 10 times as long. So these two vectors would be parallel. Always make sure you're following directions. Sometimes it just asks to justify in some way, so you could easily factor out your greatest common factor between the three components. But if it says justify using angles, then you have to use your formula and look for 0 or 180. This is all we have about angle between two vectors. Feel free to rewind, write down anything you may have missed, and as always, make good choices.